Okay, so in grade 11, if you remember, we did Lewis dot structures, and then you had to draw the bond polarity. Now, there's two types of bonds, intermolecular and intramolecular. So right now we're going to talk about intermolecular bonding. That means the bond between two atoms in a molecule. And in order to find out the polarity, you will remember that you have to find the difference in electronegativities from the periodic table. So if you look at your periodic table, it's in the left or the right hand corner. And you would remember that there was a kind of a line with these values, the electronegativity difference values between two elements in a compound. So if the electronegativity difference between the two compounds is less than 0.4, it's non-polar bond. And if the polarity or the electronegativity is between 0.4 and 1.7, polar covalent. Okay, and if it is greater than 1.7, it's ionic. And if you think about the ionic character, it just means that the one atom is going to hold on very strongly to the electron, almost so that it looks ionic. So if it's 1.7, 50 to 100% of it will exhibit an ionic character, and so on and so forth for these percentages. Then which pair of atoms would exhibit the greatest ionic character? So the greatest ionic character would be the difference between fluorine and francium, or fluorine and cesium. So if you look at where they are on the periodic table, they're at opposite ends for electronegativity. Fluorine is highly electronegative, where francium really wants to eagerly give away its electron. So this is a difference of 3.3, almost anionic, right? So when we have molecules, we have to look at their polarity. Okay, so the bond polarity, and we call this a dipole. And they show partial electronegative areas. So let's take a look at a molecule in a minute. So areas that hold more tightly to an electron, and we can show the direction of that hold with this kind of arrow. So this shows the positive side, where this shows where the electron is. So it points at the more electronegative element. So remembering that some molecules can be polar. So let's take a look at this guy. So the bonds here are extremely polar because you have carbon and you have fluorine. Fluorine is highly electronegative. If you look at the periodic table, carbon is less so. So the electron's going to spend more time around the fluorine. So here I show the direction of the bond with a positive where the carbon is and negative towards the fluorine. And I do that for all the bonds. Okay. However, this molecule is not polar. Okay. So let's take a look at another one. What about a molecule that has also have polar bonds? So here, same setup. However, I have this hydrogen here. So this kind of shows hydrogen is going to be less electronegative. So carbon's going to hold on to that electron. So this is a polar molecule because this is going to be more positive end and this is going to be a more negative end. Okay, so again, the direction of the polarity is this way. This end being positive, this end being negative. So determining if a molecule's polarity, there's a couple of things that you need to know. they're either polar or nonpolar. If all the bonds are ionic, obviously it's just going to be an ionic bond. If all the bonds are nonpolar covalent, then the polarity of the molecule is nonpolar. If there's one bond that is polar, then the polarity of the molecule is polar. If there's more than one bond that's polar, then you have to look at the symmetry around. So if the shape is symmetrical, then the molecule is nonpolar, like we saw in our previous example. So tomorrow we're going to take a look at polarity charts, and dipole moments and molecular polarity.